Good evening, everyone. I'm really thrilled to be here in Tallaght and to share with you an idea that could literally change the world for the better. I'd like to talk to you tonight about work we're doing in Trinity College, and indeed lots of other groups doing it worldwide as well, in trying to develop a new, clean, non-polluting fuel from the most abundant raw material there is, water. Our planet is a pale blue dot embedded in the darkness of space. We have a home for 7.5 billion people, and one thing we'll see from our globe, if we gaze at it from afar, is it's covered with water. Water sustains our planet. And very interestingly, what if we could use that water to generate a fuel and ensure that that fuel, when it was burnt, would not pollute? We would immediately have an immense supply of raw material. We would immediately have got rid of pollution and got rid of carbon dioxide generation. Now we'll see that the oceans cover 97% of the Earth's surface and contain most of the water. So that's my aim, that's my idea. I want to use water as the basis for generating a fuel. Now, we all know why we would like to do that, because the reality in the world for many people in the developing world is that you have immense pollution. This is a picture of New Delhi at around 7:30 in the morning. It is absolutely intolerable. So my dream, basically, is to extract a fuel, which is going to be hydrogen from the sea, using energy derived from sunlight or wind, free resources, to power our planet and sustain our technological society. So hydrogen is going to be this clean fuel. And if we combine hydrogen and oxygen from the air, we can generate electricity, provided we have a suitable device. So what I will tell you tonight is, firstly, how we generate the hydrogen, and secondly, how we use it. Now, everyone knows H2O. H2O is water. So if we want to make water, or if we want to make hydrogen, we need an energy input which will split the water molecules apart and generate the hydrogen and the oxygen. Now, clearly, we want the minimum amount of energy to make this economically feasible. Once we have our hydrogen, we then want to use it. And in this case, you can reverse the cycle, reverse the idea, and combine hydrogen and oxygen from the air in another device called a fuel cell, and liberate energy which we can use to power a car, to power a building, to power a city. And also the only byproduct which is generated is water vapor. So we have the ideal green machine. Now we can see how a fuel cell can be incorporated into a motor vehicle. It's quite compact, and all you need is to use hydrogen, which can be generated locally in your station, your service station. You pump it into the car just like petrol. It takes around the same length of time to fill a tank of hydrogen. And you can use oxygen from the air. These combine to generate a flow of electricity within the car and generate water vapor. It's a very feasible technology. The first one of these stations have been generated in London just this month. Now, what's the basis? What's the secret? I show Barack Obama here saying, yes, we can. In Trinity College, we said to ourselves, could we discover materials which will generate hydrogen very effectively? And indeed, I agree, we can do it. And the materials, the magic materials which we have used, are called metal oxides. That's a combination of a metal and oxygen. In other words, simple rust would be a very simple example of one of these materials. Now, this is a very busy slide, and it shows you, just like the Great British Bake Off, how we make these materials. We mix these metal salts together, we put them in a pressure cooker, close the pressure cooker, and then put it in a scientific oven. We heat it up slowly to about 160 degrees, hold it there under high pressure, high temperature, 160 degrees, and then leave it cool down naturally over a 24-hour period. We take the stuff out, we can dissolve it and make an ink which can be sprayed onto a support surface. And we can take photographs of the material which we've made using a very special microscope called a transmission electron microscope. This can image at the billionth of a meter level. And you can see some pictures that we just made a couple of weeks ago for a metal oxide nanomaterial that's made from iron and nickel combining with oxygen. And these materials show a fantastic affinity for splitting water into hydrogen in a very cost-effective way. It's also important that iron and nickel are very earth abundant. They're not terribly expensive materials. So it makes the metal oxide to be a very economically feasible catalyst. Now, these are very good materials for the electrolysis of water to form hydrogen. What about the oceans? Well, that's the next step. Most of the work that has been done up until now has been making a whole range of these metal oxide materials, and they can generate hydrogen fairly effectively, but the water that is used is not salt water. There's a problem with salt water. If you try and pass a current through salt water, you just won't get hydrogen and oxygen. You also get hydrogen, oxygen, and chlorine gas. And we don't want chlorine gas. And of course, if we use salt water, there's a lot of chlorine in there. You have to desalinate it, makes the whole process very uneconomic. But with getting back to our magical materials, if we have shown very, very recently, you're the first to hear about it, I haven't published it yet, but with these nickel and iron oxides, when we do electrolysis, when we pass a current through the saline solution, hydrogen is formed and oxygen is formed. Chlorine is not generated, even though the solution contains quite a lot of chloride. So this test tells us in a very unequivocal way that the materials are going to be really very good for electrolyzing seawater. So what's the scenario? We have our ocean. We can use wind turbines out in a bay. The wind energy can be used as electricity to generate from salt water hydrogen gas, which can be then collected and pumped and transported. So this discovery is going to be really very, very significant. That our dependence on oil, on fossil fuels, is going to be very much diminished. There's lots of water around Ireland, so there's no shortage of a raw material. All we need is the political will, and we need to make our voices heard that this is a very clean technology. Now, what are the consequences globally? As I said, coming to a forecourt near you, you're going to be able to get your hydrogen from the pump it into a fuel cell car. The typical distance you'll be able to travel between fills will be typically about 350 kilometers. So it's quite effective, and the top speed is quite good. What does it mean for the planet? Instead of having smog at 7:30 in the morning in New Delhi, you're going to have the equivalent of a Western urban seascape where you can walk your dog in a very pleasant environment. The planet is going to be fair to the maximum amount of people. So thank you so much for your attention tonight. It's been a pleasure talking to you.